This is the second video on chapter 18, the squeeze theorem, and I have left example 149 up from the last video. And so we're going to look at example 148, and this is similar. It's a piecewise defined function, and f of x is defined one way for a rational number and another way for an irrational number. So f of x is x squared if x is rational, and 1 if x is irrational. And so graph is a similar thing. Remember, between any two real numbers is both a rational and an irrational. So that means there's lots of rational numbers around, and so the graph is part of this parabola. And so this parabola opens upward, but not all of the parabola is on the graph of this function. Only the points x squared where x is rational. And then part of the graph of this function lies on the horizontal line, y equals 1, but not all of the horizontal line, y equals 1. So the points on the part right here are x1, where x is irrational. And so this problem was to prove that the limit as x approaches 1 of f of x is equal to 1. And for this one, we took a right-hand limit and a left-hand limit. And the reason is, as we approach 1 from the right, x squared is greater than 1. As we approach from the left, 1 is greater than x squared. So that's why we had to take a left-hand limit and a right-hand limit. The left-hand limit is 1, the right-hand limit is 1. So since the left-hand limit and the right-hand limit both exist and they're equal, the limit itself is 1. Same thing is true at -1, by the way, except that when we approach from the left, the parabola is greater than the line. When we approach from the right, the line is greater than the parabola. But we still have to take left and right-hand limits here, and then we'll see that the limit as x approaches -1 of f of x is also equal to 1.